In this video, we will continue solving quadratic trig equations. And this is page number 10 on your handout. And let's start with the warm-up problems, okay? This is Algebra 1, factoring problems. Can you factor this expression? Left-hand side, we have a difference of two squares. So we have 4x plus 1, 4x minus 1. Difference of two squares. Next one, we have a trinomial, and the first coefficient is not monic. It's not number 1. So I need to do backwards of the process FOIL method. So this is called unfoil. Or you need to try until we get the correct pairs of factors. So it's called trial and error, or error and trial. Okay? So we are using distributive property backwards to see factors. So example number 3, exercise number 3. For the interval between 0 and 360 degrees, can we solve this? So let's figure it out how we factor it, okay? So here's the question. I just use the same type of the factoring as a warm-up, okay? So let's factor the same way. So this will be 4 cosine theta plus 1 and 4 cosine theta minus 1 equals to 0. So left-hand side, if you can factor the quadratics, let's factor to linear times linear, okay? And now we are going to use a zero product property. And first factor has chance to be 0, or second factor can be 0 to make the product as 0. So we separate them, and now we have linear trig equations. So let's start with the left one, first one. Change this to basic equation. So subtract 1 and divide both sides by 4. So this is my equation to solve. And the other one has 4 cosine theta subtract 1 equals to 0. So let's add 1 on both sides and then divide both sides by 4. So we have this second equation to solve. It looks similar because it is from the same numbers from difference of two squares, right? So now let's think about finding theta r reference angles by using inverse function. By using inverse function, we can find the reference angle, right? If you have 1/4 as a number, as an input, it is okay. You will have an acute positive angle. But if you put negative 1/4 in the equation, what do you get? With the cosine, it will be an obtuse angle, okay? So do not use negative numbers in the input of the inverse function. So let's take absolute value of this, 1/4, and that is same thing, isn't it? So theta r from both equations are same. So let's use a calculator and make sure you are using a degree mode to find degrees. So let's put inverse of cosine 1/4, and angle is about 75.5 degrees. It says nearest to 10, so let's go with 1 decimal point, okay? So next step will be identifying the quadrants, right? So if we identify the quadrants for the positive for cosine, it will be first and the last, right? This will be positive. And then negative will be, all students take calculus, that's positive, and the other two parts are quadrant 2 and quadrant 3, that will be negative, right? So I'm selecting quadrant number 2 here, quadrant number 3 here. But here I need to use quadrant number 1 and quadrant number 4. Am I talking about all the quadrants? Yes, right? So answer will be from all quadrants. So what will be the answer? So let's calculate all of them, and then let's list all the answers in a curly braces for the solution set. So if angle is located in the first quadrant, theta is same as theta r. So there will be 75.5 degrees. If the angle located in the second quadrant, we are subtracting from 180. So answer will be 104.5 degrees. So that is next solution, right? Okay. And if angle located on in the third quadrant, we are adding reference angle, right? So that's going to be, let's see, 180 plus 75.5. That is 255.5 degrees. So I have three solutions so far, and the last one is in the fourth quadrant. So we are using 360 degrees. And let's subtract theta r. So we will get the last solution. Answer is 284.5 degrees. So let me put curly braces after that. 284.5 degrees. So we have four solutions in this interval, okay? If I change the interval, it can be more solutions. And that's how we consider doing quadratic trig equations. So have the basic equations and then follow the same rules for finding all solutions. Next question, exercise number 4. I need to start with factoring first. So let me use this example, okay? We did this as a warm-up, and let's use that to factor this expression. So this can be factored as 3 sine, let me use alpha, plus 2, and the other factor will be sine alpha plus 4 equals to 0. So instead of x, I put sine alpha in the equation, okay? So that is a factored form. Now we do the same way, okay? We have factored form and we will use zero product property. So first factor has chance to be 0, or second factor must be 0 to make the product as 0. So let's solve basic trig equations. To do that, we need to isolate the variable, okay? So sine alpha will be isolated. Subtract 2 and divide by 3. The other factor will be sine alpha equals to -4. That's the equation I need to solve, okay? All right, so we have two basic equations. Okay, I love this part. What is this? Sine alpha is bounded by -1 and 1, right? So can it be -4? No way. So this one has no solution. No solution at all, since sine alpha is bounded by -1 and 1. That's the range of the function. So it cannot be reached -4. So no solutions. That's good. So how many solutions do we expect for this solved equation in this interval? Maybe 2, right? So let's do the steps. So let's do step 1. So let me label alpha r as reference angle. So use trig equation with output as an input. If I use this negative output, my angle will be a negative number. So I'm not using negative angle as a reference angle. So let's change this sign. So do not carry negative as an input of inverse function, okay? Because I want to make this as a positive, acute angle. So let's use calculator. Inverse, second sine button, and then 2/3, and we have 41.8 degrees to the nearest 10th. So that's the angle measure we have from this first basic trig equations. Now let's make a decision. Which quadrants do I need to choose? All students take calculus. Which two has plus sign? All and S, right? First and second quadrants. So I should not choose this because this given basic equation has negative. So I'm choosing number 3, number 4. So quadrant number 3 and quadrant number 4, we have solutions, okay? So if we draw a ray on the third quadrant, This can be calculated from the initial rate to this by adding the quantity of theta r. So theta, not theta, let's say alpha. I have alpha this time. So my alpha solution will be from alpha r. So let's keep going. So we can have higher number than 180, okay? So we will add that. So this will be 221.8 degrees. And the other case, if we have the same angle in the fourth quadrant and I'm using 360 degrees as a calculation, okay? So it's not there yet. We have to subtract this alpha r. So we subtract this quantity and then we can have the answer. So let's subtract 360 minus 41.8. That is 318.2 degrees. So answer will be these two degree measures. Right, now let's move on to last exercise. For interval between 0 and 360 degrees, solve this. So can you factor this in the real number system? So let's use root 2 sine theta plus 1 and root 2 sine theta minus 1 as a factored form. Make sense? Root 2 times root 2 is just number 2. 1 times 1 is 1. Outer inner will be canceled out, right? So this is how we factor in real numbers. If I ask students 2x squared minus 1 factor, and Algebra 1 students cannot answer it. But Algebra 2 students can answer this using square root of 2. So it can be square root of 2 x plus 1 square root of 2 x minus 1 like that, okay? So that is how we factor these trig equations. All right, let's see. The first part has 0, or second part can be 0 by using zero product property. Since we use the difference of two squares, and I see a same pattern from example number 3, I see the same numbers other than the sign. So let's calculate. So what is basic equation to solve from the first factor? Subtract 1 and divide by root 2. The other one, what is the simplest form? Add 1 on both sides and divide both sides by root 2. So this is basic equation to solve. Am I going to have the same reference angle? Yes, right? Which quadrants do I need to consider? 2 from first and the other 2 from the last, right? So all the quadrants. Does it make sense? So let's calculate what is reference angle. What is reference angle to make 1 over root 2? 45 degrees, right? That's right. So I'm looking for everywhere in this, okay? This is 45, and what is this angle? What is this angle? What is this angle? So we're looking for all of those. So what are the solutions? 45 degrees, add 90 degrees, 135 degrees, add 90 degrees again, 225 degrees, add 90 degrees again, 315 degrees. So they are all 4 angle measures in 0 to 360 degrees. So they are the solutions of this quadratic trigonometric equation. Can I use calculator to verify? Yes, you can.